In this lab I want to see how to run an FEA analysis on a simple 3-part assembly. Since this is going to be an assembly, the first thing I'm going to do is create some components. Actually, the first thing let's do is make sure that our units are what we intend to be. So I have millimeter units, and if I go to my preferences for the simulation, I have set to metric output. Alright, so I'm going to create a couple of components. So I will right click and say new component, and then I'm going to do that again. So I'll right click again and do new component again, and two of our components are going to be the same, so I'll create the component and then copy it. So I'll go back to component number 1 and make it active, and let's rename this component number 1. I'm going to rename it as rod. And then I'm going to expand the origin on rod and turn on the visibility of the origin. I'm going to go to the right side view and start a new sketch on the right side plane, on the YZ plane, and I'll draw a circle at the origin. Now actually, as I do this, I'm going to convert the problem from, originally it was an inch problem, I'm going to convert it from a metric problem. So I'm going to dimension this circle as 1.162 IN inches. I'm going to see what that is in millimeters, and so I'm going to round this off to 29.5 millimeters. Okay, then I'm going to extrude this, and I want to extrude it symmetrically, total distance, and for that distance I'm going to type in 19.69 IN. Remember, I'm converting this from originally an inch problem into a metric problem, and I want to see what that distance is. So if I measure that distance from here to here, and I see in millimeters that's 500.126, let's change that to 500 millimeters. So I'll edit that feature and I'll change that to 500 millimeters. I'll save the file, and I need to make sure that I have it in the correct folder, and I'll name this Lab 9. Assembly 1. Alright, then I'll go around to the front view, and I'm going to draw a new sketch on this front plane, and I'll draw a center point rectangle at the origin, and I'm going to project one edge of this cylinder. So I'll do P for project, and I'll select this. If I have trouble getting the edge, I just select the cylinder and I'll say OK to that, and it projects the edge of that cylinder. At least I hope it does. It doesn't look like it actually did. It only projected the ends. Well, we'll do coincident this line to this endpoint. Alright, so we didn't really need to project or constrain the height of that, but I just prefer to have my sketches fully constrained. I'm then going to dimension this distance as 2.7 IN, and then I'll convert that. Let's do that as 70 millimeters. Alright, then I'm going to split this face, so I will do split face, and I will select, this is the face that I want to split, and from my splitting tool I'll select this rectangle and I'll say OK to that. Now actually I don't like the way that it actually put a line down here and a line down here, so I'm going to edit that sketch, and I'm going to delete that coincident constraint that I put on here. If I just delete this, then I should be able to drag that up. And let's make this line equal to that one, so I'll do equal this equal to this, and when I've done that, I see that now that I don't have that line going across the top and across the bottom over here. I'm going to split this face 2 more times, so let's go back and edit that sketch again, and I'm going to draw another center point rectangle over about here, and I'll draw one over about here. And then I'm going to make this line equal length to that line, and this line equal length to that one, make this one equal length to this one, and this one equal length to that one. I'm then going to dimension the distance from here over to here, and I'll dimension that a distance of 12.19 IN, and that comes out to 309.6, so let's put that as 310 millimeters. And then I want a horizontal constraint between this point, and also between here and here. So I'll do horizontal between this point and this point. That one turns dark. Between this point and this one, that one turns dark. Now I was expecting those to be fully constrained, and they're not fully constrained, so I'll drag it, and I see that this distance from here to here, or the center location, isn't constrained. So I'm going to draw a construction line from the center of this one to the center of this one, and then I'll do a midpoint constraint of this line to the origin. That moves it to the center. Everything is all fully constrained. Now I'm going to change this line to construction. I'll change this line to construction, and I'll change this line to construction. And then I'm going to draw a line, and actually I did this one backwards. Let's change that one back to normal line type. I'll change this one to construction. And I'll draw a line and an object line from here over to here. And I meant for that to be object line, and another line from here over to here. And I'm hoping when I finish sketch that it would split all of that, and it didn't, so I'm going to have to edit that feature. So I'll say edit feature, and I'm going to select my control, unselect this edge. I really want it to select this edge up here. Won't let me control unselect it. Click that face. There we go. Now I'll select this edge. For some reason it's wanting to select the original. Let's just delete that split and put it in again. Alright, so I'll make that sketch visible. I'll do my split face. I want to split this face with this as my splitting tool. Now why didn't it let me just change that, edit that? I don't know. We'll say okay to that. Alright, now I'll hide that. So I've split it here, I've split it here and here. I'll turn off the visibility of this origin for a minute. And I like to make these faces a different color. And so I'm going to control select these faces, and I'll go to the appearance of those faces, and I'll select a paint color or plastic. I'm going to select paint, and I'm going to do a powder coat, and let's do this color. I'll drag that, actually make sure that it's on faces. I'll drag this color to this face, and I'll drag it to this face, and I'll drag it to this face. It makes those easier. We're going to put a constraint here, and we're going to put a load right here. I will then make my second component active, so I will activate component number 2, and let's call this bracket. And I'll turn on the visibility of the origin plane. I'm going to go around to the right side view, and I will draw a circle, and then I'm going to draw a line going down from the origin. I'll then draw a line here in space. I'm going to do a midpoint constraint between this line and this line. Let's go ahead and go back and dimension this circle. I'm going to make it a little bit bigger than our rod. If you remember, our rod we made is 29.5, so I want to allow a little bit of clearance, so I'm going to go 29.6 as my hole size. So I'll do a circle 29.6. And so that circle is slightly bigger than the rod, so that the rod will slide into the hole. And then I will dimension this distance, and I'm going to dimension that as 7.865 IN, and then we'll convert that to an inch units. Let's do that as 200 millimeters. Okay, then I'll dimension the height of this as 0.79 IN, and I'm going to change that to 20 millimeters. I will dimension the distance from the bottom of this rectangle up to the origin, and do that as 2.365 IN. And let's change that to 60 millimeters. And so far we see that all of this is constrained. I'll draw a rectangle out here in space about like that, and then I'll do a midpoint constraint between this line and this point right here. I'm going to change this line to construction line. Alright, then I will dimension the distance from here to here, and let's do that as 2.375 IN, and I'm going to round that off to 60 millimeters. And then I'll dimension from this line to this line a distance of 3.155 IN, and I'll round that off to 80. Alright, then I'm going to extrude this sketch, and so let's finish sketch. I'll do extrude, and I'm going to select this area and this area, and I want to go a mid-plane distance, and for that distance let's go, and I forgot what the dimension was that we put in up here, 2.375 inches. Just measure that and see what it was, and so 60 millimeters. Okay, so let's edit that extrusion and we'll change that to 60 millimeters. Alright, then I'm going to put a fillet in this edge and in this edge. So I'll do fillet, I'll select this edge and this edge, and for that radius I want to be 0.975 IN, and we'll inspect that and see what that comes out in. Radius 24, we'll call it 25, so let's edit that and I'll change that to 25 millimeters. And then I'm going to put a fillet in these four corners, and so I'll do a fillet and I'll select these four corners, and for that radius let's do that as, actually I want this to be actually a full round here, so let's do that as 30 millimeters. Okay, I'm going to go to the bottom view and I'll start a new sketch on the XZ plane, and I will draw a line, and I'm initially going to just put it out here in space, and I'll put a circle at each end of this line. I will select these two circles and make those circles equal, and then I will dimension the diameter of one of those circles, and let's do that as 1.325 IN. I want to change that to millimeters, so let's do that as 34 millimeters. And then I want the midpoint of this line at the origin, so I'll do midpoint, I'll select this line, select the origin, and then I want this circle concentric with this edge. It all turns black, it's all fully constrained. We'll then do an extrude cut, so I'll go to solids, I'll do extrude, I'll select both this area and this area. I want it to go all the way through. Alright, and we'll save the file. I'll go back to the top level of the assembly, and so we see we have this bracket here which we're going to move over here, and then we're going to put a copy of that bracket over here. Before we make the copy of this bracket, let's load our materials. So now I'll go to the rod, I'll make the rod active and right click on the rod and go to physical material, and I'm going to set the rod as metal, and I'll set it as AISI 4130. Let's set it as AISI 4130 259. And I want to double check that and make sure that I got that material applied. So I'll right click and go to properties, and I see the physical material is set to the AISI 4130. I'll then make the bracket active, and again I'll go to properties, physical material, and I'll set that to malleable iron. Now I want to double check that, make sure to go to the properties that it is in fact malleable iron, and if I go back to the rod, I double check it, make sure that the properties of it are steel. Alright, I'll go back to the top level of the assembly. My design intent was for this width of this to be the same as the width of our split. So if I make that split visible, or the sketch for that split visible, now I'll make the rod active, and I'm going to double click on that dimension and change that to 60. Then if I go back to my assembly, now we see that that is the same width. I want to right click on my rod, and for now I'm going to select it as grounded. So we see the thumbtack here that component is grounded. I'm then going to go to the assemble, and I'm going to select joint, and I'm going to select this circle. I want to move that circle to this location. I'll say OK to that, and then I'm going to ground this bracket. So I'll right click and I'll ground that bracket in position. I then will right click on bracket number 1, and I will select copy, and then I'll right click on the screen and do paste, and then I'm going to drag that bracket down this way, and then we'll mate that. So I'll do a joint, this circle to this circle, I'll say OK to that, and then ground that bracket. I'll go into the simulation workspace and I'll select static stress. And if we select the materials, we see the steel rod that we have and the two brackets that are malleable iron. I will put a fixed constraint on the bottom of this bracket, and you might notice that I always do the constraints separately rather than do both of these with the fixed constraint. We'll see why later on, why I do these separately. Right, then I'm going to put a load on this face right here, and I want to do that load as a bearing load. I'll select the face, and then I want to put in 1,000 pounds and convert that then to newtons. So I'll do 1,000 pounds force, and it didn't turn black, so the variable isn't named right, so let's put in force. And now I see that it turns black, so I know that I have it named correctly. I'll hit the tab key, and I was hoping it would show me the newtons on that so that I wouldn't have to do a calculation. And I need to set the angle for that force, and I want the force to be pointing down, and so I don't really know what it's going to do here, whether I need to have this at 180 or whether I need to have it at 0, but let's put it at the 180. I'll notice there's also a flip direction here. I don't know why you would have the flip direction at that time. We may come back to that. Actually, when I clicked here on units, it changed that, so let's change that to newtons then. So I'm going to do 4450 newtons. Now the glyph that it showed me is not real clear on how the force is being applied and what direction it is being applied. But when we run this, we'll get a better idea. Now notice on our Precheck that there is a warning symbol here. If we click on Precheck, it says that there are some remaining degrees of freedom, and then it says click here to select manual contact, or click here to select automatic contact. So let's go ahead and select on this first one, and so we see that this rod is still free to move. So we put a fixed constraint on the bottom of this bracket. We put a fixed constraint on the bottom of this bracket over here. In the assembly environment, we had these three parts grounded. Notice that those grounded joints in the assembly environment don't carry over into the analysis environment. So we need to constrain this rod to these brackets. And it gave us another tip to either manually create contacts between these brackets or automatic. I'm going to select automatic, and notice there is a contact tolerance here. So we set a little bit of clearance between this hole and this rod so that the rod would go into the hole. You can't put a 10 millimeter rod or whatever this size was into a 10 millimeter hole unless you use an arbor press, because when you manufacture something like this, some rods are going to be a little bit larger, some are going to be a little bit smaller. You have to allow some clearance between those parts, and the clearance that we did allow was 0.1 if I remember correctly, and actually that was total. It'll find that clearance and it will create a bonded contact between those. So we'll tell it to go ahead and generate those contacts, and then if we come over here and we select edit on those contacts, we see that it put a bonded contact on one end. Let's see if it'll highlight that. So it put a bonded contact on this end, and if I click on this end, it put a bonded contact on that end. Now we have a green check mark here on our Precheck. We're ready to solve the analysis. I'm going to solve it locally. I wasn't sure if I had the direction set correctly, but we do see that it's moving down, which is the direction that I intended for it to go. And I will select the stress, and so we see the high stress in this area here, stress area in this area, and then I'll go to the displacement, and we see we have a displacement of about 1/10 of a millimeter. Expand your model component so you can see the various parts, and let's turn off the visibility of the two brackets. And so here we see the rod by itself, and I might want to see the stress in the X direction, so X positive and X negative. I'm going to go to normal, stress normal, X direction. So we see its in tension right here, its in tension right here, so the positive values in tension. And then I see it's in compression right here, and compression right here, and then the highest level of tension in this area right in here. I'm going to go back to the von Mises stress, and I will turn off the rod and turn on one of the brackets, and so then we can see, so we have a high stress area here, and a high stress area up here in this area. We can check the displacement on the bracket, and we can check, now pay attention to the values. Even though it shows in red, notice that value is essentially 0. Very little displacement on the bracket. And if I want to go to the stress, in this case I'm going to look at it in the y direction. So I'm going to do stress normal in the y direction. We see that it's in tension up in this area and compression in this area. Turn the components back on again. I'll right click on study number 1 and I'll do clone study. And so on this study I have the same materials. If I expand this, I see that I have the same bearing load and I have the same fixed constraints on the bottom of the brackets, but I want to change the contact. So I'm going to edit the contact, and instead of bonded I want to do sliding. So I'm going to select a sliding contact for both first one and a sliding contact for the second one. So now this rod can slide within those holes. If I come up here, I see that the pre-check, it says that it's not fully constrained. So let's go to the Manage tab and we'll set this remove rigid body modes, and then we'll try running the solve. Now, even after setting remove rigid body mode, Fusion gives us an error and won't solve this analysis. And so let's change one of these contact to a bonded contact. So I'll change one end of it to bonded, and now it will allow us to run the simulation. Again, we can examine our results, and if we turn off the visibility of the rod, and I'm looking at the von Mises stress, and I see the stress value on this bracket. Remember, one end it's bonded, the other end it's left to be sliding. And then I'll turn off the visibility of this bracket, and we see that the stress is slightly different on this bracket than it is on the other bracket, because one end is bonded and the other end is sliding.